Hey, good morning. Okay lang ba yung audio ko sa inyo?
Opo, sir. Okay.
Okay, so let's now discuss. So last time, so we have discussed yung BJT amplifier low frequency response. Okay, so now let's discuss PET amplifier low frequency response. So as we discussed last meeting, so yung capacitors in our amplifiers, nakaka-apekto sila dun sa gain, okay? Sa gain ng ating amplifier, then yun yung frequency na yon kasi kapag sa high and low frequencies, okay, so beyond the high and low frequency response ng ating amplifier, doon na nagkakaroon ng epekto yung capacitors sa gain ng ating amplifier. And kapag naman yung frequency is within the range or within the bandwidth ng ating amplifier, so doon nag-stabilize yung gain. Okay? So, after BGT, so let's now discuss yung field effect transistors. So, as we all know, so meron sa low frequency response, meron tayong tatlong capacitors na kino-consider, yung dalawang coupling capacitors, and yung isang bypass capacitors. So, in this case, sa FET amplifier, yung coupling capacitors, it's located on the gate and the drain terminals, while the bypass capacitor is on the source terminal. Okay, so to find the low frequency response, okay, on the capacitor sa gate, so we have 1 over 2 pi multiplied by R6 plus Zin, where Zin is the input impedance, multiplied by Cg. Yung R6, ito yung resistance dun sa ating input or sa ating signal, okay, or sa voltage signal natin. And for determining yung frequency response, the low frequency response naman ng capacitor sa ating drain terminal, so we have 1 over 2 pi multiplied by yung ZO or the output impedance plus RL or the load resistor kung meron man, multiplied by CD or yung capacitor sa ating drain. And sa for bypass capacitor, we have FL is equal to 1 over 2 pi R equivalent multiplied by CS, wherein yung ating R equivalent is equal to RS. Yung RS na to, ito yung resistance do sa ating source terminal parallel with 1 over GM, where GM is yung transconductance natin. Okay? So let's now apply yung mga formulas na to sa ating amplifier. So we have example here. Yan. So meron tayong common source FET amplifier, JFET. Okay? So we have given yung IDSS, which is 8 milliamperes. BP is negative 4 volts. So ayan yung circuit natin. Okay? So first, so to determine yung frequency response, yung effect sa frequency response ng coupling capacitor sa ating gate, so we have to determine what is our output impedance here, Zin. So Zin, so ano yung formula for output impedance of a common source FET amplifier? Zin is equal to anyone? Ano yung input impedance sa ating common source amplifier? Uy, ano yung input nito? Input impedance. Zin is equal to, wala na naman tao, napipin na naman kayo. Ano? Anyone? May sasagot ba? Napakadali eh. What is the input impedance? So we have here a common source FET amplifier. Okay, then yung biasing niya. So we have here self-bias. Oh. Ano? Z-in o input impedance. Oh, walang sasagot.
RG po ba?
Ha?
RG po.
Okay, RG. Tagal namang masabi. Okay, so therefore, our Z-in is yung resistance sa gate is the same as the input impedance, which is 1 mega ohms. Okay, so okay na. So, yun lang naman requirement ng ating FLG or the low frequency response sa coupling capacitor sa gate. So, we can now determine FLG. LG, so 1 over 2 pi multiplied by R signal plus Z-in multiplied by CG, which is FLG therefore is equal to 1 over 2 pi. Ang R signal natin dito ay 10K. Z-in 1 mega ohms. Ang CG is 0.01 microfarad. So ilan yung ating low frequency sa gate? Oh, solve. Oh, ilan? Oh, ilan? Ilan na yung na-hold nyo?
15.76 po yung akin, sir.
Ha?
15.76.
Okay, 15.76 hertz. Okay. So next tayo, yung sa may drain naman. So we have here frequency response. So 1 over 2 pi Z out plus RL multiplied by CD. So we have to determine your output impedance sa ating FET amplifier. So ano yung formula for output impedance? So we have RD parallel with RD. Okay? Yan. So yung RD na to can be determined. So RD is equal to ano? How can you determine RD? Okay? How can it be determine RD? So, kapag ito, for example, hindi given yung RD natin, RD is 1 over GOS kasi. Okay? So, 1 over GOS. So, pag hindi given, wala namang nakalagay dito yung si GOS natin. Okay. So, missing naman siya. Okay. So, ibig sabihin ito, yung RD natin is equal to infinity. Okay. So, kapag infinity yan, okay, J out is equal to RD parallel with infinity. Okay. So, di ba sabi ko, kapag meron tayong dalawang parallel resistance, okay, pag parallel resistance, okay, pag sobrang laki ng isang resistance, so ang tendency nun, yung dito, yung equivalent resistance sila is naging equal dun sa mas maliit na resistance. Okay, so therefore, yung RD natin parallel infinity, so ang magiging dating yan, ang Z out natin is equal to RD na lang. So since ang Z out is RD, our output impedance will be output is R4.7. Okay. So bakit ba paano nga ba natin mas maintindihan? For example, parallel yung isang resistance sa isang infinite resistance. So we all know naman kapag shorted yung isang line, ang resistance nito, kunyari may points tayo. Yan, point A, point B. Pag shorted yan, ang resistance niyan is 0. Okay, so therefore, kapag naman yung isang line is open, ang resistance niyan is infinity. Okay, so with that, kung yung ating RD is parallel with an open, okay, open circuit, for example, ito si RD, parallel siya with an open circuit, yan, open siya. So ano yung magiging equivalent resistance ito? R is equal to RD. So kaya kapag pinarallel mo to, si RD with infinite resistance, you will get si RD na lang mismo. So ang Z out is RD 4.7 kilo ohms. So now, determined na yung RD, so we can determine yung ating low cutoff frequency sa ating drain. Okay, so we have FLD 1 over 2 pi. Our Z out, RD is 4.7K. Plus, ang RL natin dito sa given is ito, 2.2 kilo ohms. Then, CD, capacitor sa drain is ito siya, 0.5 microfarad. So, ilan si FLD? Okay, compute?
46 po.
Ilan?
46.13.
0.13 hertz. Okay. So, ayan. Next tayo sa ating bypass capacitor. FLS is equal to 1 over 2 pi R equivalent CS, where yung ating R equivalent is equal to RS parallel with 1 over GM. So let's determine GM or transconductance. Our GM is equal to yung formula. So we have 2 IDSS over absolute value ng BP, okay, multiplied by 1 minus BGS, 1 minus BGS over BP. Okay, so given naman yung si IDSS, then given si BP, so let's determine VGS. Okay, so para ma-determine si VGS, okay, so ang gagawin natin is yung DC analysis tayo. So DC analysis, so Copyhin ko lang yung circuit. So, reconstruct ko lang ha. So, ayan yung circuit natin. Okay. So, IDSS is 8 milliamperes. RBP is negative 4 volts. Okay, so hanapin natin si VGS. Okay, gawa tayo ng loop. Ay double subscript VGS. So, VG minus BS. So, VGS is ang VG natin is 0 kasi shorted to sa ground. So, 0 minus BS. So, VGS therefore is negative IS RS. And VGS is, since yung IS natin is equal with ID, so we have negative ID RS. So, therefore, our VGS is negative 1 kilo ohms multiplied by ID. So, sa natin substitute yan? Substitute natin yan sa Shackel's equation. So, IDSS is equal to 1 minus VGS over VP quantity squared. Okay, so IDSS. So, substitute natin dyan, IDSS. So, 8 milliamperes is equal to 1 minus VGS is negative 1 kilo ohms ID. So, BP is negative 4 volts squared. So, para hindi tayo mahirapan, tanggalin ko lang yung mga units. Palitan ko ng decimal. So, 8 milliamperes, that is 0.008 is equal to 1 minus 1,000 ID over 4 squared. Okay, so we have here 0.008 is equal to 1. So minus, so negative 1,000 divided by negative 4, that is 250 ID squared. Okay. So 0.008 ay, so kulang pa tayo ID ID baliktad. Instead of the current trade into the industry before it into them. So, ayan. So, expand natin yung nasa loob ng parenthesis. So, 1 squared minus 2 times 1 times 250 ID plus 250 IT squared. So we have ID is equal to 0.08 times 1 minus 2 times 1 times 250, that is 500 ID plus 250 squared. So ilan to? Squared yung nga 250.
6,500.
Ilan?
500 na lang po yung kulang. 62,500.
Ayan. Then distribute natin si 0.08. So we have here 0.008 minus ito. 500 times 0.008.
4 po.
Ilan?
4 po.
4 ID plus yung dulo, 6,500 times 0.008.
500 po.
Ay, ayusin lang natin. So, transpose ko to. So, magiging 0 is equal to 0.008 minus negative 4 minus ID nito. So, magiging negative 5 ID plus 500 ID squared. So, ayusin ko lang. Yan na tayong quadratic equation. So, pakihanap yung roots nito. So, we can get, makakuha tayong dalawang ID dyan. O, ilan? So, ilan yung ID natin? Yung dalawang values yan. Pakisabi?
$8 milli po.
Ha?
8 milli tsaka 2 milli.
Sakto ba?
Sakto po sa akin.
Masakto po.
So, alin yung kukunin natin? Is it 8 or the 2? So, try natin i-substitute at ID, kasi pareho silang mas mababa sa IDSS eh. So, our VGS is negative 1K times 8 milli. So, VGS is negative 8 volts. So, at ID is equal to 2 milli. So, VGS is negative 1 kilo ohms times 2 milli. So, VGS is negative 2 volts. So, since ito, so sa absolute values, mababa si negative 2 volts. So, ito yung ating ID. And VGS natin is negative 2 volts. So, therefore, dito, so we can now determine our GM. So, GM is equal to 2 IDSS 8 milliamperes over absolute value of negative 4 volts times 1 minus VGS, which is negative 2 milliamperes over negative 4 ay 2 milliamperes. Negative 2 volts
Flavor dyan. Preparation pa lang eh.
okay, nawala. So, VGS negative 2 volts. So, ilan si GM?
Two ms po.
Ha?
2 ms po.
Okay, so how about sa iba? 16 milliamperes divided by 4, that is 4. So 4 tayo, okay? So therefore, we can determine R equivalent. So R equivalent is equal to, RS natin is 1 kilo ohms parallel with 1 over 2 ms. So R equivalent is 1K parallel with, so ilang equivalent ng 1 over 2 millisiemens? Ilan to? Ilan? 1 over 2 ms. Ilan? Ay, compute nga muna to.
Kailan yan?
500 po.
500 ohms. Okay? So, ilan yung R equivalent natin? So, ilan yung R equivalent?
$333.33 po.
Okay, so therefore, our FLS is equal to 1 over 2 pi 333.33 ohms times ilan yung 2 microfarad. So, ilan si FLS?
$238.73.
Ilan?
$238.73 po yung sa akin.
Okay, so ayan. So, let's graph natin siya sa bold plot.
Sir, wala po yung share screen.
Ay, wala. Yan, plot natin sa board plot. Okay, so let's plot natin. So we have here C1.
elec yan. Nakimak na 200. Hindi malikaan. Hindi number. Number 140. So, 200 plus. Hindi. Kapag yung i-disregard yung unang 140. Alam sila.
So ayan. So first, graph natin si 15.8. So FLG is 15.8 Hertz. So ano yung guidelines natin? Para ito siya yung graph. Okay? Take yung yung logarithm ng 15.8. So ilan to?
$1.2 po.
1 point?
1.2.
So dito siya. So 1.2. So malamang andito siya sa part na to. So ano yung next point dito? Ano yung next point? Ano yung next point? Ano yung next point? Ano yung next point dito? So let's take the first octave backwards.
Posan mo na yung disregard mo.
Of 1.2.
Dami na, no?
Nadoble.
Paano iba? Ganun din?
Sabihin, mula sa 133, tutuloy na 134.
Kasi ano nga mo, no?
Oo.
Parang mas mahirap pa yung yung mga nawala. Meron ditong figure dalawa.
Swerte sila.
Meron dalawang.
Ilan yan?
tinay ko lang kahapon ito, 3 beses.
Paano ba kasi nung training ko, hindi naman
2 sub-zero po ba yun, sir?
First octave multiplied by 15.8. Baliktad pala. Then take the logarithm.
Pero okay na.
Ayan. So, ilan siya?
Zero point nine po.
So, ilan siya? 0.9
9 po.
0.9. Saan ipa-plot ng 0.9? Sa? Aling point? Saan siya ipa-plot? Sa? Negative 6 dB point. So, kung 0.9, so ito siya. Assuming dito siya, 0.9. So, next, logarithm of first decade backwards ng 15.8. So, ilan? Then, paplot natin siya sa negative 20 dB point. So, ilan?
Point 2 po, sir.
0.2. So, malamang kung andito siya. So, let's say, sabihin na natin siya dito. So, yan. Plot with negative 20 dB point. Yan. Next tayo, FLD is 46 point. Ilan na yung kanina? Saan na yun? 46.13. So, ganun lang din ulit. So, burahin ko ito Okay. 46.13 logarithm.
1.66 po.
So 1.66. So malamang andito siya sa point na to. Assuming. Next tayo. Logarithm ng first decade backwards of 46.13.
1.36 po.
1.36. So, pa-plot natin siya sa negative 6 dB point, 1.36. So, malamang andito siya.
Check, di ba? Sabi siya.
Okay. Next tayo. First decade backwards.
0.66 po.
0.66. So, malamang 0.66. Nandito siya sa negative. So, dito. So, yan. So, yan. Assuming, dito siya. Okay. Then, lastly, ito yung ating, FLS is 236 at 38. 73 Hertz. So ito yung ating magiging low frequency response kasi ito yung pinakamalaki sa tatlo. Okay. So ulitin natin yung process. So logarithm of 238.73. So ilan yan?
2.38.
Point? Ilan?
2.38 po.
Okay. So how about first octave backwards of 238.73?
2.08 po.
2.08. Then first decade backwards. Ilan?
1.38 po.
So, ayan. So, 2.08. So, malamang dito siya.
38 po, sir.
Hindi, ito hindi pa sa taas. Yung una. Then, sa negative 6 dB, 2.08. Yan. Then, 1.28. So, 1 point sa negative 20 dB. So, malamang dito siya.
1.38 po yung pinakababa po.
Ay, 38. So, ayan.
Apo.
So, ayan. So, tansya-tansya lang naman. So, ito siya. So, para natin i-graph yung pinaka-response niya. So, para di kayo mahirapan, ito na may gawin yung guide. Ito yung guide nyo ng asymptotic line. Pero, kailangan nyo munang i-plot yung negative 3 dB point. Negative 3 dB point gain. So, kung ito siya, so, gagawa ka ng, so, baguhin ko lang yung tinta. So, from here, so gagawin ko ng asymptotic line mula dito. Yan. So, ito siya. So, yan yung curve natin sa board plot. So, ito yung pinaka-frequency response. Low frequency response. Then, okay, sa next meeting, magkasi tayo ng Friday, sa next meeting, yun yung last topic natin, high frequency response naman, yung sa kabilang side naman. So, paano naman tayo mag-graph pag ganito? Yan. Ibig sabihin, sa kabilang side, madudugtungan na to. Magiging ganyan itsura niya. Then, sa negative 3 dB point na yan, yung negative 3 dB point, yan. Yan. Ito, yung tinatawag nating bandwidth. Okay, so that ends for low frequency response for FET amplifier. So my question? May question ba?
Wala